Okay, let's go ahead and just focus in and look at the B quiz for the rest of the problems, just to make it maybe a little easier for the kids. So I'm going to mark this part on Schoology as the B quiz. I'll mark the other one as an A quiz. But I wanted to go into choice question number 2. 2 has the getting to the molecular formula of CH. So you have a B quiz, and it has a CH as your empirical formula. Now, how do you go from empirical to molecular? Okay, and so I want to focus on that on my next sheet of paper. Then I'm going to do the percent composition, explain what is empirical, what's not empirical. Then we're going to go into how did you guys all got this question number 5 just right, 5A. So I probably won't talk a whole lot about 5A. You all had that nailed right. And then I'll explain the last question next. But they're all on individual sheets of paper. Okay, so let's go back up to 2B. That's where we're starting in this video, and looking at how do we get from CH to C6H6. Okay, so how that is, and that might have been lost in the shuffle when you were being taught by Miss Christie, is that you have to calculate the molecular mass, the molar mass of the empirical. Okay, once you have that, that's a lower number. You're going to divide the given mass in the problem by the molar mass of the empirical. So that's what you're doing, is to get the molar mass of the empirical. So you have to get, for CH, you have to get C and H equal 13. So here's my 13, and I'm going to take the given mass, 78, divided by 13, and see how many times that makes the bigger formula, the molecular, bigger. How many times? Is it 2 times? Is it 3 times? And so here's 78 divided by 13 equals 6. So that means you're going to take C6H6 to get the molecular. The molecular can be, it's an everyday covalent compound. It can be the lowest ratio. It could be a multiple. But empiricals are always, always the lowest ratio. Okay? So let's go on to the percent composition. Now, you could take the empirical, get the molar mass of that of 13, and use those numbers to get the percent composition. But I think the easiest is to go back up to the top and see that it's out of 30 grams. So 27.69 is the carbon, but that part over the total. You're going to take the part over the total, and so that's going to be 27.69 over 30. You get 92.3%. Remember, you have to take the fraction times 100. And then you have 2.30. It's the mass of hydrogen divided by 30. That amount is going to be a whole lot less. So you take that divided by 30 to get 7.77%. You guys did pretty well on this. A lot of you didn't show your work. Anytime that you do a quiz with me, you have to show your work or you don't get points, just to point that out. Okay? Now, let's go on to the next question, number 4. From the list of compounds, circle which ones can be empirical. These are the lowest ratios. See how you can't break K2O, you can't break down N2O5, you can't break down C3H8, you can't break down CO2. These are the lowest ratio, and those are empirical. Now the multiple one is C2H6 and H2O2, and those are both multiples, so those are not empirical. That's not empirical, and that one's not empirical. Okay. Again, going on to the hydrate question, number 5. You all did really well with this. Let me show you what I wrote down. I wrote it on the other key, and I wanted to point out that hydrates have water integrated. That's the word I use, integrated in their structure. Okay, and anhydrous do not. And then because of that, hydrated are more, way more, that should have been way more than dry anhydrous compounds. So that should have said way, I don't know, way, have more mass, okay? So again, you guys did number 5A just fine, so you're probably not even need to worry about this part because you did it really well. You all understand the concept of the word hydrate and the word anhydrous. I was really, really happy to see that you understood that. Now, let's go on to the last question, okay? You have a problem with calcium sulfate, and I gave you the mass of the hydrated, the mass of the water lost, and then I was trying to save time in class that day, just giving you the moles of the dry calcium sulfate and the moles of the water. So just simply dividing the two numbers, the water moles is higher, the dry moles are lower, divide the 2 and you get 2x. That's how you get calcium sulfate and with 2 waters, and then you have the CaSO4, and then you have the word calcium sulfate. Okay, now on the quiz that you're going to take on Monday, it will not be that simple. You're going to have to divide the mass by the molar masses to get moles first. So let's go through that on my paper here. Okay, let me pass through my papers I had ready here. Okay, and I wanted to make sure you knew that you're going to take the mass of the hydrate minus the mass of the anhydrous to get the mass of water. When you have those masses, then you're going to only focus on the anhydrous mass, the one that's dry, and the mass of water. Only use those, and you're going to take the mass of the anhydrous, go to the moles of anhydrous. You're going to divide by molar mass to get that. You're going to take the mass of water divided by the molar mass of water to get the moles of water. Now the moles of water should always be higher than the moles of anhydrous, and you're going to divide the 2 numbers to get your value for the x. Okay, now in this particular example on the quiz, I gave you those 2 numbers anyways. You divided the 2 to get 2x for the A quiz, and then you had 0.2 divided by 0.049 for the B quiz. Okay, so it was that simple, but on Monday you're going to have to do the mass of anhydrous divided by its molar mass to get to moles, and the mass of water divided by its molar mass of 18 to get to moles. You're going to have to do that math. It won't be that simple on your quiz on Monday. So you guys with this quiz, please contact me on Remind if you need help. Any part of these videos that you need help on, please get a hold of me. Text me on Remind.